Assalamualaikum, hello and welcome. Thank you for watching our presentation on CHM626 case study. Our team member are consist of me, myself, I am Adiba Nabila, and my partner Nur Ilya Natasha. In this video, we will be covering on question 1 of the case study, and this is the given question. Based on the question, we are able to derive that the compound given is able to exhibit molecular formula of 6 carbon, 10 hydrogen and 2 oxygen. With this information, we are able to find the index hydrogen deficiency U. Based on the basic calculation of Cn, H2n plus 2, we only focus on U calculation, which is 2 multiplied with the number of carbon plus 2 plus number of nitrogen minus the number of stated hydrogen and minus the number of halogen. The sum will be divided with 2, so by applying this formula, 2 will be multiplied with the number of carbon plus 2 minus the number of stated hydrogen, which is 10. This will produce U with the value of 2, and the value stand for 2. The double bond will be presented in the molecular structure based on the molecular formula. This is predicted molecular structure with 2 double bond presence. Based on the mass spectrum given, the highest value shown will be stand for the molecular ion peak. This molecular ion peak will determine the weight of the compound. Based on the molecular formula, the value of each atom will be multiplied with their respective atomic number, which result in 114. Due to fragmentation, it will cause the molecular compound to excite and deviate. Based on the highest peak shown, representing the base peak that speaks for its abundant existence of ion, which is 69 mass over charge. This kind of fragmentation and value of base peak able to support our potential molecular structure. Next, based on the IR spectrum, there were also shown that the existence of CH alkene near the wave number of 3500 and CO ester near 1735, and lastly C double bond C alkene near 1650.
Now I will explain about the HNMR. As we can see here, there are 5 peaks. First peak with chemical shift 1.3 ppm have integration 3 and multiplicity triplet. Second peak with chemical shift 1.7 ppm has integration 3 and multiplicity doublet. Third peak with chemical shift 4.2 ppm have integration 2 and multiplicity quartet. And for peak with chemical shift 5.8 and 6.9 have integration 1 and multiplicity doublet. And as we can see here, all the peak has assigned the type of proton. Now, let's move on to 13C and MR. As we can see here, there are spectrum for depth 135, depth 90 and proton decouple. For depth 90, only CH peak that can be observed. For depth 135, we can see peak CH3 and CH at positive signal, while CH2 peak appear at negative signal. For proton decouple, all carbon peaks which are C, CH, CH2 and CH3 can be observed. By constructing the table of 13C and MR, we can determine each peak with its type of carbon. For chemical shift 14.2 and 18.6, it belongs to CH3 carbon. Next peak with chemical shift 61.4 belong to CH2 carbon. For chemical shift 122.6 and 144.4, they belong to CH carbon. Lastly, peak with chemical shift 166.6 belong to carbonyl of ester. Now, we have arrived at the last spectrum, which is COSY. Based on this spectrum, we can see that peak E correlate with D. Next, peak A will correlate with B and C. And we also have peak D that will correlate with peak E. Next, we have peak B correlate with C and A. And finally, we have peak C that will correlate with B and A. By interpret this spectrum, we get this structure. And this is the structure of our compound A. That's all from us. Thank you.